We're going to use the infrared spectrophotometer to acquire the spectrum of a common material that many of you know about. And that's acetone, which is in fingernail polish remover. But before we do that, we have to collect a background spectrum. Here's our machine. This is a very fine infrared spectrometer, very similar to the one that would be on Mauna Loa in Hawaii. And
what's this red blinking light right here?
that's where the sample's going to go. We're going to put the sample there in just a minute. So we've collected a background, and all these peaks through here are different vibrations of water and carbon dioxide. Here's some of that big carbon dioxide we saw on the Spartan molecular modeling program there and down here. So let's look at the molecules here. Here's water. Remember, it's a bent molecule. Here's carbon dioxide, and if it scissors, it can be bent. And here's acetone, which is fingernail polish remover. So to collect the spectrum for acetone, what we're going to do is we'll come over here and we'll take our background spectrum, and we don't want to add that to the next window. And so we're going to take a little bit of acetone right here and just squirt just a tiny bit. But whoa, not that much, David. Goodness gracious. Whoa. And we just need a drop. Oh, it came out a lot faster. That is not the best container to use. Okay, we put this on. Let's see if this is going to work. Okay. Come over and let's collect the sample. And we'll say, okay. Please prepare the sample. And we'll say, okay. Let's just hope this is going to work. And it's going to collect 16 scans. There's scan number 5, and what it does, it adds them on top of each other to get a better signal to noise. In other words, minimize the noise down there, but get good strong peaks. Now, as it's acquiring, we're up to 14 scans. Notice this really big peak right here at about 1700. That peak is the C double bind O stretch. It's stretching like this. Very, very diagnostic. These other two peaks over here are the carbon-carbon stretches. Whether it's symmetric, whether they're going symmetric or asymmetric. And then the peaks that are way up here are the carbon-hydrogen stretches. Hydrogen is so small that it stretches real fast. The carbon-carbon stretches slower, and those slower ones are down here. So infrared spectrometry is a wonderful technique to use to identify what a substance is. For example, a crime lab uses IR all the time to identify paint chip or fabric, fibers from a crime scene, for example. So this has helped determine the amount of carbon dioxide in the atmosphere.